Hello and welcome. In this video, I'll be telling you about Airpal, the 2040 meter dual bander. So I'll just give you some introduction. What is a transceiver like and what you can expect from it. This is a bidirectional type of transceiver. It's not exactly VTEX, UBTEX or anything. It is something different, but the principle is same. So it is a bidirectional transceiver, and what we have used, I'll just let you know. Let me come first with this audio amplifier. This is TDA723. This is having a very good audio output and a very good punch. So the signal will be crisp and clear, and you won't be short of any audio amplification. Before that, we have audio amplifier. This is a preamp audio amplifier for this final audio amp. So this is audio amp. We have got one stage mic amplifier. This is a single transistor mic amplifier with 2N3904. We have audio mute transistor. This mutes any noise while going from RX to TX. We have this balance modulator. This balance modulator will be using 54S diode. So you do not require this preset or this IN4148. And along with that, we have a trifler coil wound on T37-43. Crystal filter. The crystal filter is on 9 megahertz. There are two coils, L1, L2. These are 0.5 microhenry, 50 ohms. I think so. We sent out a few kits. These coils were not sent, I think so, due to some packing mistake. So I request the persons who got this kit earlier to please to arrange these two coils. These are T37-6 and 0.5 microhenry. That is around 11 turns on it. So one more thing, this is the attenuator for the BFO and VFO. In the earlier kit, we forgot to send another set for this side. So this side is lying vacant. So we request the persons to get 270 ohms, 2 numbers and 18 ohm per number to use on this side. So if you've not got on your kit these three missing resistors, please buy them and use them out here. So now we come to the IF. These both are IF. One is before the filter, the other is after the filter. So these two are IF. One transistor on the receiving side is NPN 2N3904. On the TX side, we have 2N3904. That is a PNP transistors. So both of these are PNP and both of these are NPN. Now we come to the mixer. Mixer uses BAT 54S. We do not require any 4148 to be used out here. These are the 4148. We do not need them. So these two coils are to be wound. These are 8 turns on T37-43, 8 turns trifler on T37-43. So now we come to the RF amplifiers. 2N3904 is the RF amplifier for the RX, and 2N3906 is the RF amplifier, the TX amplifier. So this is going to go further on to the band pass filter. Here we have the band pass filter. So on the band pass filter, it's very easy to use the band pass filter, since we have already given pre-wound coils for 20 meter and 40 meters. These are to be mounted on their respective places. If you have an inductance meter, you can check out the inductance. Otherwise, we have checked it, and you can straight away shoulder it. It is already wound. So what else we have? This basically relay is for changing the 20-40 meter band. This relay 3 is for changing the voltage supply to the TX and RX. Let me tell you more about the relays. There are 2 more. This relay is for 12 volt supply. So 1 minute, I think so I made a mistake. This relay is for changing the TX RX antenna. This is for changing the TX RX antenna, and this relay out here, this relay is for changing this relay 1. This is for changing the voltages for TX and RX. So this is the input out here. So this will be for changing the voltages for TX and RX. And the last relay that we have out here, this is changing the low pass filters for 20 and 40. So basically all the capacitors are already mounted. Below this we have mounted the SMD capacitors on the low pass filter as well as the band pass filter. So you do not need to mount any capacitors out here. Similarly, we have mounted capacitors out here for the crystal filter. You can see out here, these are pre-mounted. Also this 10 PF, this is also mounted basically. So the capacitors that you have to mount are 100 nanofarad basically, and a few 10 nanofarad. So these are the only capacitors, not 10 nanofarad, 1 nanofarad. Sorry, I got a few 4 or 5 1 nanofarad capacitors. So these have to be mounted, and the 100 nanofarad, and the SMD ones are mounted, pre-mounted, pre-shouldered. So okay, I have told you about quite a number of stages, though I'm sorry that I'm not telling it in a very detailed manner or very structured manner. I'm not doing that, but I just want to give you a brief view of what the transceiver is. So basically the signal that is coming out now is going to the band pass filter, or if it is coming from the band pass filter, it is moving towards this chain or RF amplifier. So basically the signal that comes out from this band pass filter is getting amplified out here. This is the pre-driver, then it's amplifying again out here with the main driver, finally going to IRF 510. So this is going to do your final amplification. One thing important to note out here is that 13.8 volt, we've got 2 points out here for voltages, 13.8 volts and 12 volts. This has to be connected always. This also has to be connected always to your 12 volts. This can be 13.8, this can be 18. It depends on what voltage you want to give out here. So it depends on that. But if you are going to increase the voltage out here, I recommend that you check C8 and this capacitor out here, C79. These have to be 100 volts and above if you are going to give much more voltage out here. Okay, and this care has to be taken regarding the RFC and this final coil FT37-43. You have to see what gauge of wire you are going to use out here if you are going in for higher voltage, but I suggest you stick to 12 volts and use the recommended wire that has been provided to you. to wind the coils. Okay, so I've told you out here also that this also has to be connected permanently to a supply of 12 volts or 13 volts. Likewise, this supply, that is the changeover voltages for TXRX, you need to connect 12 volts out here. So I think so most of the things I've told you. This is the audio mute transistor. I think so I've told you about this. This is the TX mic transistor. So basically this will amplify the signal, and through this RFC it is going to come into your balance modulator. Then it's going to mix up with the BFO and come out through the IF and crystal filter, and again to the IF, then into the mixer, and from the mixer to the band pass filter. From band pass filter to the driver to the main driver, split driver, main driver, then to the final MOSFET, and after the MOSFET to the low pass filter. Okay, so I think so I have told you most of the things out here. Most of the things I have covered out here. I don't know if I have left anything else. We have got 2 points out here. This is going to the BFO, this is to the BFO. These are going to your BFO that we have provided. So you can mount an SMA connector out here, and through the pigtail it will go to the BFO. I'll show you that also. I'll show you a constructed Airpal transceiver. So I think so I have mentioned everything out here. Maybe I'll look up again if I have left anything. So this is the supply going to the transceiver. We are basically providing 8 volts. So from 12 volts it's going to 8 volts. The 8 volt is being distributed to the various stages of the transceiver. And we have 7805. 7805. This is for the biasing of the Airpal. So the biasing you can keep at 50 milliampere, or I think so if you set it to 2.2 volts, if you set the gate at 2.2 volts also, 2.5 volts, that should sufficiently drive the MOSFET. So okay, let's see something. Let's have a look at these connectors. What we have J5 is the mic PTT connector. Okay, this is the BFO, J6 is BFO, J7 is the VFO, and this is J4 volume control, J3 speaker, this is 12 volts J1, this is for LED RXTX, this is the band change, this is the band changeover. This has to be connected to the DDS, which provides 5 volts out here. On the default it is on 40 meters. So when you press the encoder switch once, it will give a voltage of 5 volts. The relay switches and it changes the band to 20 meters. So I think so I made it clear now how the band changes. It changes with a positive voltage of 5 volts coming out from the Arduino Nano that is programmed through the firmware. So what else we have? Antenna and 2 RX antenna. Okay, I'll let you know one thing, a very important thing out here, that this RX antenna and this point out here, G8, these two have to be connected through a jumper. These two will be connected through a jumper. Now you would ask, why do we place a jumper out here? We placed a jumper out here so that if we had some connection or if we had some track out here, this may have caused some problem in the circuit. So to avoid that, we used a jumper out here. Where does G8 go? J8 is basically coming from the low pass filter. It is coming from the low pass filter. So we are getting a signal that is coming through the antenna. In both the cases for TX-RX, it is coming through this point. It's going to the low pass filters 20 or 40, getting switched, and after that it is coming to this point J8. And J8 we have to connect out here through a coaxial cable RG174U that has been provided. I'll show you in the build transceiver how it is looking. So this relay will basically block the signal, vice versa. So basically this has to be connected. I'll have to go much more in detail to explain you this, but I think so this can be sufficient. So I think so I've explained most of the things. Anything else left? This is a speaker, 12 volts that I've told you, LED, band change. We have covered everything out here. VF4. I think so nothing is left. This is IRF. You mount the IRF out here. Yeah, one thing more. We have sent you in a kit 2 of these resistors, 10 ohms, 1 watt. Just mount one of this out here and leave this. Put a jumper out here. Leave that resistor. Only use it if by chance you are getting any parasitic oscillation. Otherwise don't use it. Your power will drop. So don't use that. We had to do all these things to make it certain that anyone does not have a problem. So if someone has a problem, it becomes difficult. So we had done this to see later if someone is having a problem. So let us put a resistor out here. But after trying out, we found that the power was decreasing. So this is not required, and the set is very stable. So you won't require this. So I think so I've told you most. Now I'll bring up my other set, which is built Airpal, and show you. This is basically a semi-constructed one. Some parts are still missing. Actually, I'm building this up for maybe some customer. So I built this much. Still some work has to be done. So I'll show you in another video that is only followed by this, the build set. Okay, welcome back. This is the second part. Of this Airpal. Details about Airpal. So this is the one I made. The first one I made after getting the PCBs. But it is not the very first one I made. I made a couple of these on other PCBs, and this has been the final one which came after getting the PCBs. So now I can show you how everything is connected since this set is fully wired up. So what we have, we'll start with this DDS. What does this DDS have? This DDS has the Arduino Nano, which is we are having a firmware. We have a module for SI5351. Actually, if you see a crystal out here, this is an external crystal mounted. What happened? We got these modules from China, but when we use these modules, we found that the crystal, the oscillator, the crystal that's being used was not of correct frequency, and we were getting a large error. We were getting an error of around 2-3 kilohertz. So we had to remove that crystal and use a normal one. So this is a normal crystal. It's functioning perfectly okay, and we get a perfect signal out of this, and we have got a fully calibrated set. So this is the module SI5351. We got 2 clocks out here. The third clock is not being used. So let me show you now. These are 2 clocks. This clock is, the first clock I'll show you is clock 2. This clock 2 is going to the BFO. So clock 2 is going to the BFO. I think so. Now if you are going to build this set, I have shown you clearly where this is going. It does take a lot of time and documentation, and nowadays Video is a better medium, though we try to make some more documents. We'll try to do that, but it's become much easier to make a video and explain it. So this is the BFO. The second one we have is clock 0. So where is clock 0 going? Clock 0 is going to the VFO. So I hope you get idea now where both of these connections are going. So we have got the input for VFO and BFO, both from these two positions. What else we have now? We have this 12 volts 12 volt supply going into the VFO BFO. I think so you should take extreme care out here. If you don't accidentally use 12 volts somewhere else, then it is certain that your nano is going to suffer. So be very careful. Give 12 volts near this 7805 connector only, not anywhere else, because in that case I would believe that this nano is going to burn out. What else we have out here? Let's see. Audio in. What is this audio in? So basically this is the chip LM386. This is taking a single input from the volume control. We have this volume control on the back out here. From the hot end, it is having a point taken and given out here. So basically this is going out here to LM386, and from LM386 it's going to the Arduino Nano for the bar graph display. So basically that is how your bar graph is being generated through this AC voltage coming from the audio amplifier through this 10K volume control. I'll show you. This is a 10K volume control. This is the wire. This is the wire. It's connected to the hot end. Where is the hot end? See, this is the hot end. I think so. It is in the center point. That is the hot end. So it is coming to this point, and it is the input for this LM386 audio in. So it's clearly written out here. So we have 12 volts audio in, and what else we have? We have this. This is the connection for band change. So this gives a 12 volts voltage, and we have this band change. Wait a minute. This one. Band change mode. Band change. Sorry, it is out here. So this is a band switch, band change. You just cut the wire. See where it is going. You can trace this out. Yeah, it's going out here. So this is a band switch. Basically, it gives a voltage out here, and basically your band is going to change. The low pass filter and the band pass filters, both will change. So you got this band changing out here. So let's see what else. The thing I told you out here was this point. This is a very important point. This point. This I told you. This RX antenna I told you. This is connected through a coaxial cable out here. So this out here. Yeah. You need to connect this. It's not necessary you mount SMA connector out here. You can mount this connector, 2-pin connector out here as well as out here also. You can mount this connector and shoulder the wires. You may not require this SMA connector out here. Because sometimes what happens, if your SMA connector is having some issue, it won't connect and that creates a problem. So I suggest that you shoulder the wires directly out here. So I hope I'm clear now about this connection out here. This will basically will be required out here. Okay, we are back. So I told you about this cable. So this is J8, this is J9, J8, J9. This has to be connected together. So because this is bringing the antenna for your TX and RX to this point. So from here it is getting switched over to the band pass filter. It enters to the antenna through the low pass filter and to the band pass filter, where it goes to the RF amplifiers of both the stages. So basically now I'm clear. I hope I made it clear how this patch of cable is connected. We have got the IRF final out here. So this 12 volt connection has to be also made common to the 12 volts coming to the main board. Yeah, to the main board. So this connection is to be common in the supply. I'm using a fuse out here. This actually case is not for Airpal. It was for SSB ITX, so which I'm using out here. So for Airpal we are trying to get another case built. So these are the low pass filters. These are the band pass filters. So I think so I've made everything much quite clear. I think so there should be no doubt. So now let me show you the front. This is the front. I'm using for testing. I'm using you have been provided this mic. You can wire this along with. I think so I forgot to send this connector. I should have sent. I'll try to include that in the kit. So basically, through a stereo connector, you can make a connection like this. This is for the testing purpose. If you don't have a PTT mic, so with this wire you can touch this, press as a PTT switch and modulate. I'll show you a demo also how I'm using this mic just to test it. Once you have a commercial mic, you can just plug it in out here. This is your LED for TX RX. You can use this connection for a headphone if you wish to. This will be your volume control and this is your main tune. So out here, if I turn this, what do I have? I have this 12 volts. This actually I had kept in SSB ITX. If you wanted to provide a higher voltage, so you could use this port on-off switch and cut out here for the MOSFET to get some ventilation. Antenna connector. This was actually an extra antenna connector. So this was a BNC type, where this BNC type comes out. So this is for basically cabinet for SSB ITX, but I was just using it out here for Airpal until we get it a home. So that's it. I think so I've shown you most of the things, and I'll just give a short demo of the TX side, how much power it is putting out. For RX I don't have a proper antenna in my office, but I think so I have put up some videos where you can see the reception of Airpal. So I'll just give a short demo again now of the working TX. Thank you.